today we mainly want to understand a full understanding of this particular law right here. And this is called Ohm's Law. Now, I know you guys have heard this, even you beginners have probably heard that. I know you know the term ohms, you hear it in your resistance when you're being talking about, oh, it's got so many ohms and all. Well, this is why. Ohm's law states that the current flow in the circuit, the current, that is amps. Current is always spoken of in amps. The amps. So, the current flow in a circuit, the current flow, the amperage, in a circuit, your electrical circuit, is equal to the voltage divided by the resistance. The voltage divided by the resistance. Now, if you've never seen this written down before, if you've never heard it spoken before, even if you have, you need to understand that this equation, this law right here, governs the understanding of an electrical circuit. Now, I want you to write this down. I want you to get this understanding in your head. The amps, the amperage flow in a circuit, an electrical circuit. And what is an electrical circuit? It is a deal where you have a battery. Perhaps, let's just take as a car, we have a resistor here, we have another resistor here, we have another resistor here, and then we come up. These means that there's work being done. This would be a load. 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 R1, R2, R3. And this is your battery. This is your power. Okay? This means that as long as there is current flowing in this circuit, there is work being done. Okay? There is work being done. Okay. So, the current flow in a circuit is equal to the voltage. So let's say over here we have 12 volts. And the current flowing in this circuit is 2 amps. Okay? Now what is this circuit? This circuit right here, where you have everything in a series, the current leaves the battery, it goes through the load, the second load, the third load, and returns to the battery, the power source. That is called a series circuit. Series circuit. This is a very simple series circuit. This is our first circuit that we're going to study with the use of Ohm's law. A series circuit. Okay? So, we know there's two things that you're probably going to always know in a car when you go out there. You can always do a parasitic draw. You can even do put your meter in line and do an amp draw. You can use a low voltage amp probe like the one I have here, the one I showed you. You know, you can plug that in and get a low draw just by clamping it around the wire. You can put your meter in series and all those types of things. But what are you finding out? You're finding out the amperage, but you still have to take and see, is that amperage correct? Is that the right amount of amperage that I should have in this circuit? Well, how do we know that? Well, we're going to use Ohm's law to understand that. Now, I want you to make sure you have all this written down over here, because I'm about to erase it, but I'm going to leave this circuit up here. Okay, because we need to understand the circuit. But make sure you have this down, because we're not going to go over it again. We're going to just keep moving forward, okay? Let me erase that. Now remember what that said, because you're going to need to remember the wording of this Ohm's law. the way it's spoken. But by the time we get done, you'll understand it. Until then, just keep it in mind what we've written down and what we've spoken here so far, okay? I know I'm moving kind of fast right here, but in the world we live in today, attention span is not very long, so I just want to make sure I don't lose my viewers and that you guys just hang in there. Especially you young guys that think this is all overwhelming. You're probably saying to yourself right now, oh, what good is all this going to do me? But you hang in there. If you just let me finish with you on this first introduction, you'll understand here in just a minute. Okay, now let's go ahead and take this down. We know we're studying electronics. We've been here long enough in the classroom, we'll call it, in front of the board to understand it. We're going to go on now. We're doing a study of physics, the control of electrons in a circuit. This is not just your, this is not a game we're playing here. This is serious technology. And you've got to get the basics nailed down before you can do anything. You know you got to learn the basics of something before you can move on. If you don't learn the basics, you'll never nail it down. GoPro, stop recording. Okay, so what does this tell us? That tells us that as long as we know two of the parts of this equation, that we can always figure out the third one. And then also we can always test against our math. And we can work it out three ways so that we always know that when we are done with a circuit, if these three compute together and the sums are matched and everything works out to copacetic, then we know that our circuit is good and there is no question about it that it has worked itself out. Okay, now there are a few things that I want to make sure that we understand about DC current, DC circuit, and the voltage in the DC circuit. Okay, this is a simple series circuit, a DC series circuit. Very simple. Now, first thing I want to make sure you understand is that when connected to a circuit, a DC voltage causes current to flow in one direction. So here we have the battery. Let's just go as we're reading this. Okay. Here we have the battery. Let's say this battery is, the chassis, let me explain something here. Using the chassis as a common connection significantly reduces the amount of necessary wiring in electronic equipment. Most electronic equipment is made with the printed circuit boards. So what I'm trying to say here is in computers, if you don't know this, as in cars, the chassis or the frame of the car is actually part of the electrical circuit. That saves on wiring and all kinds of problems, especially with direct current. And why would that be? That's because if my battery, which you know it is, when you come out of the battery on the negative side, the first thing it's going to do is it's going to ground to the body somewhere. And then you're going to have several chassis ground points somewhere in the car. You know, you'll have one coming from the motor, and then you'll have one coming or from the engine. Then you'll have one coming from other parts of the engine. But they're always grounded to the chassis. Okay? Now the reason that is because if I want to pass current from this resistor and it's on a circuit board and I have several other, things on there, I can't have wires running all back to this battery to the positive side, can I? No, instead, what will happen is it might be positively turned on, but then it receives, once it's the positive side is open, then the power can flow from that device from the negative side, or it can be positively controlled. But either way, it is grounded to the chassis. Everything working in the car is going to have a ground to the chassis that will return the voltage back to the battery. Now that's just all there is to it. A series circuit is a closed circuit. So remember, your chassis, the frame, is the ground source for the current to leave the battery, do its work, and then it comes back to the battery through the positive side. I don't know if that makes sense to you right now, but believe me, that is the way it works. Okay? So we know that using the chassis as a common connection significantly reduces the amount of necessary wiring in electronic equipment. Understand that. All right? Voltage sources use common points called grounds. A point in the circuit may be either positive or negative with respect to the ground. Batteries and generators connected in series aiding will add their voltages. In series opposing, their voltages subtract. Now that's a little more complicated or deeper than I want to go today, but we will get into that. Current flows in all parts of the system at the same time when voltage is applied. Now that's another thing you need to understand. You might think that like water going through a circuit, you know how it takes time to fill your hose up and all that, because sometimes I'll use water referral when I'm trying to make it simpler to understand the flowing of electricity and how electricity and force and all that type of thing works, and I probably will use it again to explain. But the fact is that well, whatever. The fact is that with electricity, let's say, you know, each one of your devices are here, and if it's turned on, if it's in series in this circuit, believe me, as soon as you turn that switch on, it's not like that's got to go from here to get to here and get there and all that. Electrons. Let's just imagine these are electrons. These are electrons. These are the electrons. As soon as that power is turned on, every one of these electrons start to move instantly, unless it is being controlled some way to not, or to slow down. But I'm saying in a circuit, it's not like it's got to wait for this to get here. You know as well as I do, if you turn a light switch on or off, you're not going to get in the bed before that light turns off, or you're not going to get out of the bed before that light comes on, because it comes on instantly. There is no delay in the electrical current. So, you know, get that out of your mind. It's all instantly energized. Now that's important to remember down the road, believe me. Current flows in all parts of the circuit at the same time instant when voltage is applied. Current, voltage, and resistant units may be conveniently expressed in smaller or larger units for ease of measurement. That's something will become important later on. Voltage is the electrical pressure or force that sets electrons in motion. Now that is something we got to get a clear understanding of, okay? Voltage. Voltage is force. Now what does that mean? I know you've probably heard that before, and maybe you have a clear understanding of it, maybe you don't, but we're going to make sure you do before we're done today. This is important that you understand this part for sure. Well, it's all important, but this is a little more hard to understand, so I'm gonna use what we'll call it, a simile, a metaphor. Well, we'll just use something to compare it to that's a little easier to understand. Okay, now this is going to be an example of a series circuit over here. What we're looking at over here, okay? But we're going to use water. I was just speaking of it. Now this is why. Let's say we have a tank of water up here. Now this is 10 feet off the ground, and it has 50 gallons of water in it. 50 gallons. That's pretty heavy. But when you add it, you put it up in the air, say 20 feet. We have 20 feet of pipe here from one end to the other. 20 feet. Okay? Then down here, we encounter a valve. A valve. Okay? And this valve is releasing half a gallon an hour. Per hour. Okay? Then the water that is being released drops down into a recovery tank. Down here we have a pump, and this pump is taking this water and it is pumping it back into this tank. Now the tank has a regulator in it to make sure that the water level never drops below a certain amount. So if we have a full tank up here and it's set to never fall below this amount, then it's going to have an actuator to keep it on and all that type of stuff, okay? Now, how does this resemble this over here, okay? Let's say we have 12 volts here. This is our force. That's our force. We have 50 pounds of water up here. This is our force. It's a force caused by the weight of the water and gravity. What is that, 14.7 pounds per square inch? Forcing down on this top. This is gravity forcing down on this. This causes force. Force right here to push down, which causes pressure. Pressure to build here. Because there's a release being made. So then when the water is released, it's pumped back up here, and so you have a closed circuit. That means that you never run out of water. You get a little, little dissipation, but even that is set to where it has a little valve, and so what would it have over here? It would have a water supply coming in, so that whatever evaporates or gets lost or dropped, it gets refilled, so that the tank never runs out of water, even though it might dissipate a little as it's being evaporated away and lost and leaked out or whatever, okay? But over here, this water supply keeps it coming. And what is the water supply coming into a house most of the time? 40 psi, okay? Now, why is that so important to what we're trying to do over here, okay? Because we need to understand where the force is coming from that keeps this water flowing down here. Okay, what is this? This is a closed circuit. A closed circuit. You see how the water could never run out because it has a supply that replaces it, and then it has a way to return to where it's coming from. It's being metered out so that it will even have the valve as the meter, and it checks it all, okay? Now, here is the difference over here. Or this is the similarity of how water can be considered similar to a flow of electricity. We have a power source here, 12 volts. That's the amount of force that we have. Now, the flow, the amperage, the flow, the half-gallon flow over here, this will be considered amperage over here. The amperage will be determined by the amount of resistance total of each resistor in the circuit. We have 3 resistors, so how are we going to figure out what the current flow is in this equation? As long as I know 2 of the variables in this equation, I can find out what the current should be. And if it's not, then I know I've got a problem somewhere in my circuit. As over here, if I'm not getting the amount of water that I want back over here in the amount of time that I want it, then I know I got a problem in my flow. Either I've got a leak, either I'm leaking water out here somewhere because I'm using way too much water to keep the water going. This valve is not set correctly, and my light's overheating. I got to turn it off for a second. Excuse me. Yeah, those lights are getting hot. I'm going to turn those off for a minute. I believe we can still see the board. Okay, I hope we can. GoPro, stop recording. Okay, sorry for the interruption. So now we see the similarity between the water circuit and the power circuit. One thing I didn't mention over here, that this water supply over here coming from that would be your alternator. Over here, this pump, you wouldn't have that, of course, over here, because your flow is going to be determined by the voltage in your battery. Because remember, as we read earlier, the voltage and the resistance will affect the current flow. Now we're going to see why that is. Here is one of the forms of the mathematical equation for finding out the current in a circuit, and that's associated with Ohm's law, and that is this. Now remember, there's going to be 3 different forms of this equation, but this is the one where we want to find out current. Now what did we see? What was the term we used a minute ago? I. All right, here's 3 abbreviations that you're going to absolutely need to know, and I know we covered it, but that was I equals amps, E or V equals volts, R equals resistance in the equation. So we want to find out the current flow, and what is how to find out the current flow? Write this down. You're going to need to know it. I equals V divided by R. Okay? Now, which 2 of these expressions do we know? We know 12 volts. We have 12 volts here. we have 3 resistors. Now how are we going to know what they are? Because resistors have color bands on them, which will tell you the amount of resistance that resistor will build up towards the flow of electrons. So how do we get the total of each one? Well, in the equation we're going to need to know what they are. So that would be R1 plus R2 plus R3, and then we get the total. That would be RT. That would be the total of the resistors, all those resistors. So we know that we have rings, so we're going to call these 2 ohm resistors. So we'll give each one of these resistors a value of 2 ohms. 2 ohms. 2 ohms. Okay? So if we have R1 plus R2 plus 3, that gives us 6 ohms of resistance. Okay? Now if I equals voltage divided by R, and voltage is 12, and resistance is 6 ohms, I equals 2 amps. That means that when the power leaves this battery, it travels, and it is traveling at the circuit with the current is flowing at 2 amps, as long as the voltage stays 12 volts. And what will keep that voltage at 12 volts? It will be the voltage regulator and the alternator. The alternator is as similar to here as the out pressure coming in to the house or to the tank to keep that pressure at that. That would be your alternator, and it's going to keep it at, and if it's charging, usually your circuit is going to be anywhere from 16.6 to 14 volts. That's because it's a higher charge, because it's making up for the amount of loss that is being encountered as the current flows through each one of these resistors, and that is going to happen, and this is what we're working our way around to here. We're trying to find out voltage drop. This is the most important part of what all this has been about here. I'm trying to explain to you. We are trying to figure out voltage drop in the circuit. Voltage drop in the DC circuit. And how do we determine that? Well, you're going to always have a little bit of voltage drop in your wiring, but if you're wiring sound in a small circuit, say 10 feet with small wire, 10 gauge or 12, 13, you're not going to have a whole lot of voltage drop. And a really sensitive equipment, you would have to figure that out. But when it comes down to what we're trying to do when you're troubleshooting on a parasitic draw, that type of thing, you know, you consider it, but what you're really looking for are the big loads. Are they dropping properly, or are they dropping at all? So where you're actually going to be measuring, let's say if I'm going out there and I'm wondering if my starter is working properly, it's running slow, that type of thing. I'm not sure if my batteries is putting out enough amperage. Maybe I got a weak cell or whatever, even though I'm showing 12 volts there and stuff like that. Well, what I do, I would put my voltmeter across the battery connections as I crank the car, and I would read, this is my meter, I would read the voltage drop across the battery. So now I want to figure out the voltage drop. Let's say I know what my total circuit is supposed to look like. I'm supposed to have 12 volts. I'm supposed to have 6 ohms of resistance, and which is supposed to give me 2 amps of current, 2 amps of current flowing through the circuit. 2 amps. That's if all my resistances and the total of my resistances and my voltage stays the same, always stays the same. In other words, my alternator is working properly, my battery is discharging properly, all my resistances are working properly, then I should have a constant of 2 amps flowing in my circuit. I know you can understand that, okay? But let's say I'm not getting that. Now let's say my battery's good, my alternator's good. We're going to determine that right now, that the battery's good. I've checked it. I've got good flow. My alternator's good. I've got 14 volts when I'm running. The car's running. When I check the current, you know, or the voltage at the battery with my meter. But something is not right. My current is not right. My current is too low, let's say. Okay? So what have I got to do? I've got to go to my resistors, and I've got to know my wire's good, I know my battery's good, my alternator's good. That only leaves my loads. My loads might have a problem. Something wrong in there. So I would come here and I would do a voltage drop test on each one of these. Why am I doing a voltage drop test, you say? What is a voltage drop test? Well, a voltage drop test is the amount of work that the voltage has to do, the electrons have to do to get through this resistor, or to make it do its job. A fan running, a light putting off. Anytime you have something doing work, it's producing heat. If you have something producing heat, it's absorbing current. Okay, voltage, electrons are working. So when it goes across this load, what happens? As in anything where heat is produced, work is done, you have a voltage drop across that load. Okay? And it is set. If that resistor has those lines on it, it should only be dropping just so much voltage. If it's dropping not enough, or dropping more, or none at all, then you got a problem. So how would we find this out? All right, here's another equation. Now we have learned one equation here so far. I equals V divided by R. But how do I find out the voltage drop across here? That would have me looking for voltage. How do we find voltage? There are three forms of Ohm's law to prove a circuit. The second form we're going to learn is how to find voltage. If I know two, then I know the other one. And I know I've got 12 volts, but that's not what we're looking for here. We're looking for voltage across a load. So it doesn't, this matters in a sense, but we're going to be looking for this one. So V equals the current times the resistance this time. This is the equation we're using, not this one. That was to find amperage. This one, we're looking for voltage. Okay, so we use this one, voltage. V equals I times R. All right, what should our resistance be? Our resistance should be 2 ohms. Okay, so how would I find the voltage drop for that? All right, well, I know the amperage is supposed to be 6 amps, or let's see, we determined it was 2 amps. So the voltage drop across that would be V equals 2 amps times 2 ohms of resistance. That means the voltage drop across this resistor right here should be 4 volts. This should have a 4 volt drop coming across it. So in a closed DC circuit, when I measure here coming from the negative side of the battery, this is my first resistor I encounter. I should have 12 volts in a good circuit. On the other side, coming out of this one, I should have 8 volts on a good circuit. The amps never change. Remember the rule we spoke earlier? Even though there's voltage being used across this, we have a voltage drop because the work has been done. The amperage does not change. The amperage stays the same in this circuit. It will change if our voltage drops. If our battery stops charging, if it starts getting down to 11 and 10, it will immediately change the current flow regardless of the resistors and all the other things, because the current flow will be affected by the resistance if it changes, and the voltage, okay? So now, we get over here and we come to the next resistor. Same thing. Let's say this resistor is working fine. It has the 2 ohms of resistance. It has the 2 amps flowing, of course. We have 8 volts, but that doesn't matter. We still are in a closed circuit, and so we're still looking for voltage drop. We're not worried about the voltage at this point because we're in a closed circuit, but we're looking for the voltage drop. We still have current flowing at 2 amps with force, because we have force over here. So just remember, we have V equals 2 times 2, and the voltage drop equals 4 volts. Okay, 4 volts, 4 volts here, 4 volts of drop, just like we had before. And now what we had here was 8, and now we have 4 coming out. As the voltage continues, we come up here. Let's say now this resistor, all of a sudden we got a problem. We got a problem in this resistor here. This resistor right here is only working at half it's weakened. So it's only drawing 1 ohm. Okay, we're going to call this a bad one. Okay, we only have 1 ohm being drawn here. Now what happens? How does that affect? Okay, we have again, we want to just measure. We're looking for voltage across this, so we're not going to worry about the voltage that's coming up there. We would if we were making measurements, but you know, if we determine that we have what we should have, then we're going to leave it alone at that. But we're looking for the voltage drop across this one. Now we have a change because we have only 1 of resistance, but we still have everything else the same. We still have 2 amps of current. We have only 1 of resistance. So now what's going to happen here? We have the voltage drop across this is only going to be 2 volts. So let's write our 2 volts up here. We lost 2 volts. Okay? So that leaves us with 2 volts. Our 2 volts drop across this resistor right here. 2 volts lost. We should have lost 4. So now we have 2 volts here that we weren't expecting to come back to our battery. We have 2 volts here now returning to the battery. Shouldn't be there. So now we say, well, let me add this up, because we know that the voltage drops, the voltage returning and everything to the circuit should add up to the amount that the source or the force has been producing. So we come down here, we have the 4 volt drop. Okay? We have a 4 volt drop over here, so we take that 4 volts on resistor 1. 4 volt drop on resistor 1. We have a 4 volt drop on resistor 2. We come down to resistor 3. It should be 4 volts. What is this? We should have 4 volts, but instead we have 2 volts on resistor 3. What happens is, instead of 12 ohms of resistance in the circuit, we have only 10 volts. Excuse me. We have only a 10 volt drop RT. Okay? Now when we should have been reading 0 over here, instead we're reading 2 volts. We got 2 volts coming back, and it should have all been used. So that right there would tell you the current flow, the voltage coming in, the voltage coming back to right here is not right. It should not be there. There should not be any voltage present there if this circuit is working correctly, or if it is, it should be very little. Let's say now that you're working on a starter, and a starter is not resisting. It's not passing current through the starter to the ground. Of course, you know it's not going to work. So when you go over there to do your jump across your battery, like we spoke of before, you're not going to get the proper reading, because the battery is not, the starter is not consuming the amps and dropping the voltage across like it should. So you're not going to get a proper reading. That's one sign when you're trying to figure out on a starting system. But we're going to go from start to finish on that, so let's stay away from that for now. Right now we just want to concentrate on the math. Okay? So we realize that on our RT total, we're not correct. Okay, now how else is that going to affect this equation? So we've got voltage coming back that we shouldn't have, leaking by, because we've got a bad resistor up here. And the way we would tell that is the voltage across that. We would do voltage drop on each one of our resistors, and we would find out which one is weak. If we did not have any current when we first started this, if there was no current on any one of these resistors, we had no current showing back up here or anything going across that battery, we know that we would have an open. That means current is not flowing. If you have a break in your line in a series circuit, I don't care where it is or what it is, you will not have current flowing. You'll have voltage present to wherever the break is. You'll have voltage right up here. You know, if you didn't have resistance here and drops, you would still have whatever voltage you would have would be present here. You would have nothing here because you've got a break. But let's say one of these resistors, if that's a diode or something, and it's leaking. Let's say this one was just leaking current back straight into the chassis. It's coming back. not affecting the current really, but what it is doing is it's dropping the value of the load, the voltage drop across this resistor. This is why you must understand voltage drops. You have to learn how to read a voltage drop and understand what a voltage drop is. Now I want you to just go back over this time and time again, get on the internet, Google it or whatever, but you need to understand voltage drop. It's so important. The known values of the voltage, you know the amperage, but you don't know the resistance. You think you know the resistance, and you can look at the specs. Let's take a starter for instance, a bad starter. You can look at the specs on a starter and it will tell you on the papers, or you can look it up, how much resistance that starter coil, that motor and all that, when it engages, the trying to turn the engine over, that all is resistance. How much resistance is built up in that circuit? How much should it be? And so once you know what the established number should be, then you can use this equation. R, the third equation for working with the Ohm's law. Let me look it up. I should know it, but I can't remember it. Now, we know the values. We know the values of the current. We know the values of the voltage, but we don't know the resistance, but we want to make sure it's right. But we think it's off. So let's make a little space down. Let's make a little space right here. Let's erase this a little bit. I hope you had that down there. Okay, so our third way to check the current flow in a circuit, we're going to use R equals V, that's voltage, divided by current. So we don't know the starter resistance, but we think it's bad. We think that it's this circuit's shorted out. Maybe we're not getting any resistance at all, current flowed through it, but we want to check it. So we want to see what our resistance should be. We know our volts, we know we have 12 volts, we know we have 2 amps of current. The resistance coming across that starter in this equation right here would be 6 ohms. 12 volts divided by 2 amps of current flowing in the circuit would mean that starter should build up on just the starter circuit 6 ohms of resistance. If you go and you put your meter and you put one side of your meter on that starter body and you touch, let's just say your test light. You put your test light there on that starter, and that 6 ohms should light up a test light pretty good. And you touch it to the body and all you're getting is just a tiny flickering. There's hardly nothing coming off of the bulb. You put your meter on and you're getting something like 0.002 2000 millivolts, and 2000 millivolt. You realize that something is wrong. I mean amperage. You're just not getting anything. You're not getting any ohms, or your meter just reads 0, or it's reading just a paltry little amount of resistance. Then you know you got a problem, because everything, the voltage drop across it just will not be right. And that's a good way to figure out if you got a bad starter or a bad solenoid. And you don't have to go changing a battery and buying a starter, guessing. Just take your meter, get down underneath there, do a voltage, do an amperage reading, resistance reading, voltage drop across that starter, and take your test light. But test it before you start changing parts, and this is how you do it. So I'm going to just we're going to stop right there today. That's enough on Ohm's law and how to figure out a simple series circuit. Now we will review this again. I'm not going to go back to the water thing because I'm afraid that might be too much or might be confusing right now. I hope it's not, but don't worry. We're going to stick with this. I'm going to be doing these videos as often as I can. And I just want you guys to comment on my page. Let me know if you're able to follow it. Let me know where you might be stuck. Email me. I'll be posting that underneath the video when I post it in a place where you can get a hold of me. I'll start trying to maybe do a live thing and all that. Just give me some comments. Let me know if it's helped you. Let me know if it hasn't helped you. Let me know if it's doing you any good. Let me know your complaints. I'm not one of those kind of people that has thin skin. You can tell me whatever you want to say to me. You know, it's only words. If it's constructive, then I'll use it. If it's not, then I'll do what I have to with it. But I'm not going to get offended by it. I mean, look, I'm not a teacher. I'm not a professional teacher. I'm not proposing to be a professional teacher. But I am a professional in my work, and I try to do the best I can. And you know, the only way you can do the best you can is you got to You got to learn. You got to apply yourself. You know, you got to learn the basics of things. If you're going to work with electricity, my friend, you got to know the basics. If you ever expect to get anywhere with it, you're going to have to learn the basics. And this is the basic knowledge. So what we have covered today, we have covered Ohm's law. We have covered 3 forms of Ohm's law to try to figure out the current in a circuit. If you don't have current flowing in a circuit, you got a problem. So if we want to find out the voltage in a circuit, we use this expression, I times R. Voltage, amps, resistance, R, I, V. Okay? If we want to find out the current flowing in a circuit, we have current equals voltage divided by resistance. We want to find out the resistance in a circuit. We use this again to find out the resistance in a circuit. These are the 3 forms of Ohm's of how to prove mathematically Ohm's law. And what is Ohm's law? Ohm's law, that current flow in a circuit. Current flow in a circuit is equal to the voltage. The voltage is equal to the voltage divided by the resistance. The voltage divided by the resistance. Ohm's law. So I hope you guys got something out of this, and just hang in there. And like I say, just leave me a message up, or ring the bell, leave a message, and let me know if you need some of these. Maybe I can take some pictures of some of these diagrams if you didn't catch them this way. If it was too hard for you to see on the board or whatever, just let me know. But I know some of you guys, you've been doing this so long, this is elementary to you. But this is not meant for you. This is meant for those guys who have no idea of what they're doing out there on electrical, and they're scared. A lot of they should be scared. You know, you can mess up a lot of things. You start fooling around with these meters and setting them on DC amps, and you start letting current flow through a circuit freely, you can do a lot of damage. And I know you can see it from what we've been showing you here on the board today. But let's stop with that today. Let's remember where we're at. We have covered Ohm's law. We understand that current flowing in a circuit, you measure the current flow to know if you have your circuit properly. And you learn your voltage drops. You got to do your voltage drops across each one of your resistors, because it's going to affect the overall voltage and current flow. So that's the relationship between it, and just study a little deeper, you'll get it. Okay, we'll see you next time out in the shop. GoPro, stop recording.